still in good shape.
Oh my God.
All right, so here we go. This is the Airplane Systems Guided Flight Discovery, Chapter 2. For those of you that are following along in the Pilot Handbook of Aeronautical Knowledge, or the PHAC or FAC or whatever they call this thing, this is a combination of chapters 3, 7, and 8. Okay? 2 hours ground, an hour ATD. We're supposed to take 3 hours total on this, so let's get started. And a couple of different types of fuselages. Open truss, stress skin, monocoque, semi-monocoque. These are all design characteristics of an airplane. Wings, monoplanes, biplanes, different control, different flight controls, which are your ailerons, your flaps. The empennage, the French got involved in this somehow or another. The tail section, they call it an empennage. Vertical stabilizer, horizontal stabilizer, rudder, elevator, stabilator, trim tab. A couple of different things, right? A lot of flight controls, and we'll show pictures of, and I got a little model here for it as well. Main wheels, conventional landing gear, tail wheel, nose wheel. The beloved nose wheel. Oh my goodness. Okay, tricycle gear, fixed gear and retractable. The scope of this course is to stay on that fixed gear and not really talk about too much the retractable. An oleo strut. Again, the nose gear. I love the nose gear. Every pilot should just love their nose gear. All right. Disc brakes. It's another one of mine. Differential braking, power plant, engine firewall, propeller, pilot operating handbook. That's a part of the airplane equipment that has to be in the airplane. The airplane flight manual. Difference between these two, you'll see this a lot. AFM/POH. The airplane flight manual is for that exact airplane. So that's registration 41 Mike Echo. That's registration 737 Bravo Alpha, whatever it is. What in the world is this all of a sudden? I don't know. All of it, that is for that exact airplane. Okay? The POH, these are things that we can get online or anywhere else. It's generally for Cessna 172 or for a 152 or a Piper Arrow, whatever. Okay? Annual inspection and 100-hour inspections. Preventative maintenance. Airworthiness, directions, kind of operation, and I think we're talking about special flight permits, okay? Okay, here are the major components of the airplane. I need to at least know the major components of this airplane. Fuselage, this is where we sit, and generally speaking from the firewall back to the empennage, or if it was a pressurized airplane, that rear pressure bulkhead, okay? The empennage is the tail section. I know it's not, oh, there's listed right there. There's the empennage. That's just the tail section of the airplane and includes vertical stabilizer, horizontal stabilizer, a rudder, and an elevator. The wing, these are typically attached together and through the fuselage with a spar. The power plant and the landing gear. Those are your major components. Okay, we see my guy here. He's flying one of the very early model truss type airplanes. All right? And this truss type airplane, is there a way to get rid of that? That truss type airplane was just put together with cables and connecting each one of the two wings with trusses. Okay, this was very, very early, and there's really no fuselage at all. The guy's just hanging out there sitting on his seat. Okay, cool. So no fuselage on this one. Remember, we were talking fuselage before. This is very similar to the fuselage that you'll have in the airplanes that you fly for training. This is an inside view of the fuselage. If you look, the fuselage also has these devices or this structural component. These are called formers. It forms the shape of the skin. The skin is on the outside, and that would be the part that we could touch, the part where the registration is written. November, whatever in the world is written on the outside of this. Attaching each one of these formers, and you can see here I have an actual bulkhead, or something that forms with rigidity, right? Attaching each one of these are longerons. That's what this one is called right here. And stringers. Now, each one of these increase the rigidity of that fuselage, increase the rigidity of that airplane. A little bit of extra weight, it's all sheet metal, so either aluminum or sheet metal, so still very, very lightweight. But each one of these has a little bit of extra weight, and this is what's called a semi-monocoque design airplane, which, if you remember when we first went through the key terms, they had monocoque and semi-monocoque. So this is called a semi-monocoque airplane. If it were a monocoque airplane, it would not have these longerons and not have the stringers. It would just be the formers and then the stressed skin. So in other words, the skin will maintain all the loads of that airplane. Remember looking at the Cirrus that we had on the video, 678 Delta Golf, and we've probably heard Cirrus in training airplanes before. The Cirrus is a composite airplane. It's built out of plastic, and it is a monocoque design airplane. So it does not have longerons and stringers. Instead, all it has is a rear bulkhead and a firewall. And all of the skin maintains the flight loads as we fly through the air. Whereas here, they're shared by the longerons and the stringers. Okay? This is a very lightweight design, but if you think about how the sheet metal design works, remember the Cirrus is all composite. It's built out of carbon fiber and some sort of plastics, right? If you think about how sheet metal works, consider a Coke can, right? You got a 12-ounce Coke can or a beer can or whatever. I have this Coke can, and that's fine. I could put a lot of weight on it. I could probably even stand on that Coke can, and it will maintain its shape. But if I poke it just a little bit on the side, then it'll crumple, right? The same thing would happen with this if I didn't have the longerons and the stringers. So this is the semi-monocoque design. Without that is a monocoque design. All right, a couple other things. Biplane, monoplane, right? That has two wings, that has one wing. Okay, fine, kind of easy. Easy to go with there. Flaps. Flaps are controlled by a lever inside the cockpit. You push it down, and they're either electric, as in the case with the 172, or they're manual. This is the case with a lot of Piper airplanes, which we had a Piper airplane not too long ago, and you just pull a lever. That lever had a linkage that went straight to the flaps. The airplanes we fly now, you push this to whatever setting you want, and then an electric motor drives that flap down to the preset selection, okay? On the back side of the wing, of course, these are the flaps. You see where the flaps are. They are close, what's called the wing root. That's the root of the wing, or the part of the wing that's closer to the fuselage. And then all the way out here, you got the wing tip. The flaps are at the wing root. On the outside part of the wing, these are your ailerons, okay? Are these familiar terms? I think some of these you might be okay with. Has anyone not heard any of these terms yet at all, ever, before now? Okay, that is a great thing. I'm loving this class more and more, okay? All right, because the ailerons are on the outside of the wing, and it's important that I know flap, aileron, that's easy, but where are they at? They're built that way for a reason. And the reason is because the airplane is able to fly at cruise speed, relatively fast. Well, we could say relatively fast, 120, all right. All right, cruise speed, or I could fly it very slow. I could fly somewhere around 35, 40 knots, right? Very, very slow. Depending on how fast I'm flying this airplane in level flight, I may be very close to no longer being able to support the airplane in the air. There's a condition called a stall, where the airflow separates from the top of the wing, and I no longer produce enough lift to keep it flying. When the airplane stalls, it's also designed, these engineers are pretty good at what they're doing, and they have a complicated mess of problems when they start with. I started in engineering school. I understand and have some sympathy for some of the engineers. But one of the things that they did is they built this wing in such a manner that it will stall here first. It will stall on the... Now we can see the engine. It can stall here first, okay? So now what happens is I have maximum control of the airplane using my ailerons, even though I'm flying very, very slow and maybe very close to a stall. Well, that's bittersweet because if I do stall the airplane, I don't want to use the ailerons to control it at all, because then we could increase the likelihood that we enter a spin. Now, it was, I think, Tuesday, Wednesday, whatever day, my days are all confused right now, but it was one of those days where I did a spin flight with a pilot in a 172. So they fly very, very well. And I've probably logged, hundreds of hours and spins of all the different years that I've flown with flight instructor applicants. So it will spin and it's fine. There's nothing wrong with it. You don't want it to happen to you if you weren't expecting it. Okay? And that's one of the ways that the engineers have designed this thing with the ailerons on the outside. Number one, it gives you the most amount of arm, right? Or the most amount of power while you're trying to bank the airplane. It also gives you the maximum controllability while you're close to a stall. So that's why the ailerons are on the outside. Okay. It's not uncommon to have some part of the airplane fall apart when I'm flying it. All right, or at least in a scenario. Now, it says when you turn the wheel to the right. I love that. This is a control yoke. And if you know any Spanish, you know the Y is usually a J. So we have a lot of Latin students in Florida, and they call it a control joke, which is a joke to me, and I think it's funny. So here's your control yoke. The right aileron moves up, and the left one moves down, if I do it like that. Okay. So everybody, if you would, 2 thumbs up, just like this. Just put your hands right in front of you, 2 thumbs up. Okay. Turn to the right. That side aileron goes up. Make sense? Thumbs up, aileron up. You can see it. Just like that, that side aileron goes up. All right, so if you ever wanted to figure out which, I'll see pilots in the testing center and they're doing that. Now watching them on the video camera. Oh yeah, he's doing it. Look at there. Anyways, turn it to the left does the exact opposite. Okay. Vertical stabilizer. This is your vertical stabilizer. And this is the horizontal stabilizer. Not this part. This part has a whole nother different name. This part has a whole nother different name. And that part has another different name. But this is your horizontal stabilizer. This is your vertical stabilizer. Wait until we get to aerodynamics. You guys are right then will decide if you like me or not. Okay? Because we're going to get into stability. Okay, rudder. This is your rudder, this part. Now, something that Jeppson did not do is they did not address this in their picture. And that is called a ground adjustable tab. It's adjustable by maintenance. It's not for pilots to go out there and fiddle around with. But if the airplane flies just a little bit off one way or another, maintenance will adjust that on the ground. Okay, but it's something that you and we do not mess with, but it is a true trim tab, a ground adjustable tab. Okay, elevator. There's the elevator. Who rode the elevator up here at one point in time today? Did everybody took the stairs or somebody rode an elevator? Which way does the elevator make us go? Up and down. Easy. They made this stuff easy. Hey, if they made it for pilots, it was probably supposed to be easy. Okay, so there's your elevator. And just one back. They didn't also mention this here. I think they do in another slide. This is your trim tab. And it'll show me in one of the subsequent slides exactly how to adjust this. And I want to spend a little bit of time talking about the trim tab. Okay. This is a stabilator. And this is an anti-servo tab. This is a great example of one of those things that I told you we're not going to spend a lot of time on. Because you won't fly an airplane with one of these during your training program, okay? This is called a stabilator because the entire surface moves. And you'll see sometimes the larger jets, the transport category jets, they'll have the entire stabilator will move instead of just having an elevator at the back. So it's something you might experience as you fly. If you fly with Piper, if you fly a Piper airplane, you will have one. And then instead of having a trim tab, it has an anti-servo tab. Again, these are things that exist, but we're not going to spend a lot of time talking about that. This trim tab, we will. Your trim tab here allows you to relieve, control pressures. That's what this allows you to do. Oh my goodness. For those of you that have attempted, anyone solo yet? Has anyone solo? You've soloed? Anyone soloed? Anyone else soloed? I guess I have. Not too much, but most of the time I got somebody in there with me. Okay, so for those of you that have flown a little bit, you understand that as you start flying the airplane and you accelerate and decelerate, you're going to feel some feedback on the control yoke, or what my Spanish friends call the joke. Okay? You'll feel some feedback on this yoke. And that feedback comes in forces, control forces. Okay? So I'm constantly, if I want to keep the nose exactly where I want it, I got to continue to push. And why am I pushing? I'm using my muscles to push on this thing. That's going to be a very aggravating flight. I'm flying 3 hours pushing on this control. This is terrible. That's what your trim tab is designed to do, to relieve that control force. So I use now I don't have to use any, perfect. The airplane's exactly where I want it to be, and I'm not pushing or pulling on the controls, okay? That's how you use the trim tab. And this is exactly what it looks like in the airplane. You've got a neutral setting here. It'll show you how to set for takeoff. You put it right there on that index mark. You just roll down like that. That makes the nose go up. Right? You push the wheel down. That will trim the nose up. If I push the nose forward, that trims the nose down. But you can't use this to fly the airplane. So don't roll the wheel and then expect, okay, that's going to make me climb. You set the climb with your yoke, and then if you have control pressure, you relieve the control pressure. All right, so fly these things properly. Another example of things that we're not going to talk about too terribly much, the tail wheel airplane. If I'm flying in snow or on mud or on dirt, gravel, whatever, it's useful for me to have the propeller away from all that mess on the ground. So a tail wheel does that nicely. These airplanes perform nicely on that. We're not going to fly them. We're not going to fly this either, but not for a little while. And this is a transport category airplane. You can see, has the exact same components. What's all this part right here called? That's it. How about this? Uh-huh. And this? Okay, power plant, right? Which works the exact same way that the piston engine works, okay? It's the exact same thing, but just a couple different components, okay? What about this part, all this back here? Okay, what about this? Vertical stabilizer. This one? Horizontal stabilizer. Okay, what's on the back of that? And the back of this? Okay, and underneath here? Landing gear. Right. Unless you got a flight engineer or somebody who's back there goofing off. I don't know what they're doing. All right. Here we go. A couple different airplanes. Retractable gear, fixed gear, like we mentioned. That was part of the key terms in this chapter. We're not going to spend a lot of time talking. We did have a Piper Aero. We used to teach a lot in these. The commercial pilot program before 2018 required that you spent 10 hours on a complex airplane, and you had to take the commercial pilot check ride in a complex airplane. Okay? Does anybody know what happened to change that? What happens to change? What happens that makes everything change? Yeah. So there was a pilot examiner at Embry-Riddle, and they were flying a Piper Aero. Embry-Riddle. Anybody heard of Embry-Riddle before? Kind of a big school, all right? So this is not, you know, your shade tree mechanic out there with an airplane trying to teach somebody how to fly. This is a big place. The wing fell off during the exam, and it crashed. Well, they both died, right? The applicant and the pilot examiner. And 3 weeks later, the rule changed. And you no longer have to fly one of these for a commercial pilot certificate. Bad day for Piper. And in fact, we sold our Piper almost immediately following that. A lot of flight schools did too. I still like them. I think they're good airplanes, but. And you got your fixed gear. Now, question for you real quick. Is that a complex airplane? Yeah. How do I know?
We don't know if it has a propeller.
I might not know, yeah. Unless I know about Piper arrows, I can't tell if that's a controllable propeller, right? What about flaps? Does it have any flaps? I don't know that either. Well, this one is complex because I know that Aero builds this, or the Piper builds it. It's called an Aero, that says it right there. And I know that this does have a controllable propeller and flaps, okay? All right. Main gear. Ooh, boy. All landings occur on the main gear first. Okay? Let's make that even better. Because there is such a thing called a crosswind landing. Anybody ever heard of this idea called a crosswind landing? I hope so. Let me tell you right now that nobody is good at it, okay? When I say nobody, I mean very few pilots, the very rare couple of people out there that exist percentage-wise know how to land an airplane crosswind, okay? And I'll ask student pilots all the time, okay, how are your crosswind landings? Oh yeah, I know how to do it. Those are great. Those are really, really good. We spend a lot of time, me and my instructor, number one, I know that your instructor doesn't know how to do it because I've flown with him. Until you get 2,000, 3,000, 4,000 hours, you're not going to know how to do a crosswind. But try. Crosswind takeoff, crosswind landing, all of it. Let me tell you what, the pilot community is terrible at doing these things. But we're going to land on which gear first? The main gear. Start thinking right now that you're going to land on the upwind tire. That's where you land. If you guys would just land on the main gear, I'll be happy. That would be great. Not the nose gear, in other words. But on the upwind tire. Now I start thinking that whichever way that wind is coming from, I probably need to land on that tire first. And the idea is, as the airplane slows down, I use more and more aileron, and then gravity slowly brings the downwind tire to earth. And then I gradually release and bring the nose wheel down. Now, for those of you who have flown on Aeroflot, American Airlines, Delta, Turkish, whatever, Air Portugal, they're usually pretty good at it. Anybody that has ridden on an Airbus, they're almost always good at it, and you know why? Because Airbus lands it, okay? The pilot has nothing to do with that landing, okay? But for those of you that are flown, these are the pilots that know how to do a crosswind landing. Most of them. Occasionally you'll have one where you can tell the FO landed and he screwed it up here. She screwed it up bad, okay? But anyways, on the upwind tire. Now, here we go to my nose wheel. Ta-da! Isn't this a great looking nose wheel? This is a really nice looking nose wheel. Do you guys know what that thing right there is called? I'll tell you. What's that? That is your shimmy damper, right? That's a real thing, yeah. But this, what kind of strut? Nose wheel strut. Okay, what kind of nose wheel strut?
Metal.
Anybody like Oreo cookies? Or you guys know what Oreo cookies are? Oreo cookies got the black cookie and then the white center. Okay, Oleo. I don't know who in the world named this. The guy must have been named Oleo. That is an Oleo strut, okay? Meaning that this is a strut and it has a cylinder above it, And that cylinder is charged with some sort of spring or usually gas, nitrogen, okay? Has fluid and nitrogen inside there. And it allows for a nice smooth landing. Now, which landing gear do I land on? The upwind tire of the main gear. Then the other one comes, then I allow that. But sometimes it doesn't work out just that way, right? Okay. Ta-da! Anybody see anything wrong? Let me take a sip of my coffee and somebody tell me if you can find out what's wrong. There's something wrong here.
There are no cans of oil inside.
Well, there's plenty of oil inside. It shouldn't be so close. But, whoa! This is the cylinder. The strut goes into there. That's a bolt that should go through this hole. Okay? Somebody landed this airplane very hard and broke the bolt in the entire strut. And you can see, like you said, there's nothing here. No strut here at all. Okay? Don't do that. I got plenty of examples of what not to do. Believe it or not, I haven't done any of these. I haven't bent or damaged an airplane ever. At this point in time, it would just be embarrassing if I did. I've never done anything like this. But we got pilots that have less than 40 hours that have done stuff like this. Okay. All right. So there are two types of landings. There are good landings, and there are great landings. Anybody heard any of this before? Okay. There's only two different kind of landings. A good landing is any landing that you can walk away from. It's a good landing. True story. A great landing is any landing that you can walk away from and we can reuse the airplane. Okay? So this was a good landing. All right. Brakes. Okay, everybody, you got a driver's license? No? Everybody else has a driver's license? Okay. When I first started flying, I did not have a driver's license. I had a moped when I was 15. I took my written exam when I was 15. But I didn't have a driver's license. So, anyone seen the brake calipers on a car or a truck? How big are those? Big, right? You see on some of these Mercedes and some of the Porsches, you see they paint them red and they paint them yellow, all kind of nice. You know, that brake caliper is this big. Hell, the car's not even this tall, and the brake caliper is huge, right? How much does that car probably weigh? It'd save you the trouble, somewhere around 3,000 pounds. Remember the old metric okay. So somewhere around 3,000 pounds or so, right? How much do these airplanes weigh? Well, about 3,000, 2,500 pounds, 2,400 pounds, somewhere in that. Okay? Now imagine I have 4 brake calipers on my Porsche like this. Okay? And how big are those tires? Well, my back tires are like this wide, right? And the front tires are like this wide. Look at this tire. This is a skinny, stupid little tire, okay? Look at this brake caliper. It's only this big. It's very, very small. You won't get a lot of braking power out of this thing. Use aerodynamic braking. Make the airplane fly slower as you approach. Don't stall before you touch the ground, right? But make it slower before you approach. There's a little bit of medium ground there, okay? Don't get on the ground and apply these brakes like you're driving a 2020 911 with anti-skid and everything. This thing does not have very good brakes at all, okay? The other thing is, when you're taxiing, not the taxis, Uber and all that, but when you're taxiing the airplane and taking it out on the ground, you're rolling on the ground and you're going out to your runway, don't put your feet on the top of the pedals. Because then you got the airplane, I see it all day long. You got the airplane at 1,500 RPM, making all kind of noise, and the airplane's barely moving. And they got the brakes on, okay? Don't do that. You're just putting a lot of heat right here on the brakes. If I need those brakes for a rejected takeoff, well, they're not going to work as well as they would if they were cool. All right, a couple things about brakes and brake systems. Now, this is a hydraulic system, and almost every airplane will have this as a hydraulic system. Hydraulic systems typically, well, they run wide arrangement of different things. Landing gear, retractable landing gear, they'll have that as a hydraulic system. Flight controls, you'll have that as a hydraulic system. You'll have all sorts of different hydraulic systems depending on the airplane that you're flying. This airplane has one hydraulic system, and it's a very simple hydraulic system. There's a master cylinder behind each pedal. So each pedal on each side has its own master cylinder, which is just a way of transmitting hydraulic pressure from your toe through this line to the brake caliper. Okay? Each pedal has its own brake mechanism, so I can push on the top of the pedal on the right side, it'll make the right side brake activate. And then I can push on the left side, it'll make the left side brake activate. I can push both together, and they'll make both activate together. Okay? I can use differential braking, but remember also, this thing turns. The nose wheel will move just a little bit right and left. It's not instant, so you don't get that very fast response. Push the pedal all the way to the floor, and it will gradually come over to make those small corrections as you're taxiing a long ways. If you guys have looked at an airport diagram, you have almost 1.5 miles of taxi to get out to runway 9. You've got a long ways that you're taxiing before you get out there. That's a long ways of riding brakes if you're trying to steer it with differential braking. If you're trying to steer it just with the nose pedal and a little bit of power, then that's perfect. That works out really well. Takes practice though. Okay, power plant. This is our machine. This is a different type of airplane. I understand that. You can see the firewall in the back, which just means if there's any kind of fire that's produced by this engine, any sort of combustion that occurs on the outside becomes an external combustion engine, then that fire will separate from me. It's separated from me with this firewall, okay? And then you've got the motor mounts that bring it over here to the different cylinders and to the engine crankcase. Now, we start talking pistons, crankshaft, crankcase, connecting rods. Who is vigorous thumbs up right now? They know exactly what I'm talking about. You. Okay, there's my technical group. Who is, yeah, I get it. That's okay. That was me. Yeah, okay, all right. Don't get terribly involved with a lot of the internals and the mechanics of this thing just yet. That will come naturally. There's a couple of things that you need to know about this so that you're able to understand how the machine works and able to understand how you can control it. But we don't need to reinvent internal combustion here. We don't need to build an engine, in other words, so that you guys can become pilots. All right, this engine is called horizontally opposed. Horizontally opposed because the cylinders on this side are exactly in line horizontally with the cylinders on this side. Okay? This part of the engine is called the crankcase. Inside the crankcase is a crank. Okay? And the crank is what transmits the power from the cylinders to the propeller hub and the propeller. All right, so crankcase inside here, something that we can't see on a subsequent slide. I'll show you inside the crankcase, and you'll see the crank. There's a crank in there, and that crank is connected directly to the propeller hub. Directly, and that is a great thing that you said that because it's bolted to that crank. Some airplanes, and we have one of these airplanes, have gear reduction. Means that the engine spins at 1 RPM, but then that RPM is reduced to the propeller. These propellers are generally 75 inches. So somewhere a little about 6 feet or a little more than 6 feet in diameter. Okay? If it went any faster than 2,800, 3,000 RPM, you would have serious separation at the tips because it exceeded the local speed of sound. So there is a maximum amount of revolutions per minute that we could have of this propeller. If the engine turns in excess of that RPM, then it has to be reduced through gears. Okay? You won't fly that airplane in the training program. Not for private pilot, not for instrument, not for single engine commercial. All right? And in fact, you may not ever fly one of those engines with gear reduction until you get into turbine airplanes and turboprops, okay? Key point is that that crank is connected directly to this. If this crankshaft inside the engine turns around one full 360 degrees, that propeller turns around all the way 360 degrees, okay? Now, kind of food for thought here, this is called a flywheel. I don't know why they called it a flywheel, but they did. That flywheel has gears on it. Okay, it has gear teeth on it. This is what allows us to start the airplane electrically. Long time ago, you got the guy out there swinging the propeller, doing hand prop. No one's going to do that, ever. Okay? Instead, we'll turn a key, and that key will close the circuit for the starter. The starter will momentarily engage the flywheel and spin rapidly so that the engine can start. What's very important is after the engine starts, like immediately after, you have to release the starter. You don't want to continue to hold that starter because a couple things happen. It's breaking the starter and it's not letting the engine run. It will slow the engine down so it won't run. Okay? So this is part of the starting mechanism. Now, inside the crankcase, there's a thing called a camshaft. Forget I ever said that because they will never mention that in any of the books. But there's a camshaft that goes through here, has lobes on it, and these lobes push a rod out to the valves. And the valves open and close and either allow air to come in through the induction system or to escape through the exhaust. So I got cylinder heads out here. These are the valves. These are the cylinders. And inside the cylinders are pistons that move back and forth. This is the basic components of the internal combustion engine. Don't go even anywhere close to beyond that because that's all you need to know. Okay? Let's take a look at a couple of these things and then we'll talk ignition and so forth. All right. Remember that that engine was horizontally opposed and it had cooling fins on each one of the cylinders. These are air-cooled engines. What cools our car engines? Liquid, right? They're liquid cooled. You have zero liquid going through the engine in the airplane. Zero. You have oil, okay, but there's no cooling liquid that goes through this at all. The only thing that will allow the airplane to dissipate heat is air going over those fins. So, if I'm going to make a before takeoff checklist, which I do every time, and I advance my throttle and check the engine and make sure it works, point that airplane into the wind so I get the maximum amount of airflow. Right? We're on the ground, we're at a moderate power setting, point it into the wind, allow maximum airflow. If I'm taking off and climbing, use a cruise climb. You know, don't climb like this. Well, it's not really going to climb like this anyways. But climb with just a nice shallow pitch to allow more airflow and allow me to see out the windshield for traffic, terrain features, weather, whatever the case is. Okay, AFM. There it is. See all these sections coming across the side? They're tabbed out. All modern airplanes, modern meaning like post 70-something, are all divided into sections. And each section corresponds to exactly the same on every airplane, and that is general. How much does it, where was it built? How was it, what kind of engine does it have? Just basic stuff like that, okay? What's the wingspan? What's the maximum weight? Limitations is, okay, now I got, these are the airspeed limitations. These are the oil pressure limitations. These are the fuel limitations. Those are all your limitations. Then, sections 3 and 4, you guys will be in these all the time. Emergency procedures, checklist. Normal procedures, checklist. That's where all that comes from, okay? Performance. Section 5 tells me this is how much distance it takes for the airplane to take off. How much it takes for it to land. Crosswind component that I might have. Fuel and time distance to climb. How much fuel am I going to consume on a normal cruise flight? Right? This is all your performance. Weight and balance. How do I know what the maximum weight is for the airplane and where I can distribute that weight? Right? To make sure that the airplane remains controllable. That's kind of an important thing. Airplane systems. Airplane and systems description. So that's where it'll go into exactly what the airframe is made out of. What kind of material? What's the structure type? What's the landing gear made out of? What kind of landing gear do we have? What's the environmental system? In other words, how do I get cooling in there? There's no air conditioning in these airplanes. Yay! It gets hot in Florida. What does the heating system look like? Any kind of system. And then handling, service, and maintenance. I usually don't do much maintenance on the thing. We don't wash it. Somebody else washes it. This is a nice to know section. Supplements. Truth be known, all of these airplanes that we fly have a Garmin 430. Well, back in 1980 when the airplane was made, there was no such thing. So when they added it, they had to add a supplement to that AFM. And then safety and operational tips. Usually Mr. Cessna or whoever over there at Wichita, Kansas will go through and say, okay, yeah, thunderstorms are bad, avoid microbursts, and they'll give you a little lecture on what to do and what not to do. Nice little information. Okay, along with this airplane, I get an airworthiness certificate. That airworthiness certificate is issued the day that airplane became airworthy and will never expire. Now, I always tell, and I just use both words, but I always tell people, if you hear someone say either one of these two words, think about it. Always or never. Because they're usually not true. People exaggerate a lot. This is absolutely true. This will never expire. Okay?
For all times?
Never.
For all times, never expire the standard airworthiness certificate?
Standard airworthiness certificate.
For all times, in America?
Forever.
God bless you.
I love it, comma, unless. Unless you don't maintain it properly. So there could be certain things that come out. But yeah, God bless, this thing will never expire. As long as I maintain that airplane and keep up to date with the maintenance, always good. Okay, well, here it is. What are my required inspections? Every 12 months. 12 calendar months. It has to have an annual inspection and an emergency locator transmitter inspection, the ELT. ELT, if the airplane exceeds a certain deceleration or a certain acceleration value, it'll start sending out a signal. And that will alert, hey, there's probably a crash here, okay? So search and rescue can find us, all right? That annual inspection has to be done not by a maintenance technician, but by an inspector, a maintenance inspector, an airplane inspector, okay? Those are required inspections. You guys see this where it says 12 calendar months? The FAA is kind of interesting, and it makes it easy, it really does. But unfortunately, it could be confusing if you're not trained properly. Calendar months just means go 12 months and then the last day of that month. Okay? So if I had my annual inspection done today, My annual inspection is good, it's valid, until next February 28th. Unless next year's not a leap year, is it? Probably, all right, whatever. So it's good all the way until the last day of that month, 12 months from now. Okay? Every 24 calendar months, we need a transponder. Next gen is a kind of cool thing that's happening with our airspace system. It's going to put all of ATC, most of ATC, out of a job. Yes. You can tell my bitter likingness of ATC. But phase one was a Mode S transponder, which means that our registration is transmitted to the ground. It's transmitted in all directions, but it's transmitted by anyone that's receiving that. So Mode S transponders became a requirement for civil aircraft in the United States January 1st of this year. So we have to have that, and it's required for an inspection every 24 calendar months. Altimeter and static system, if we're operating under IFR, that has to be inspected every 24 calendar months. So I don't need that stuff, not for VFR flying. Every 100 hours, if it's used for hire, every 100 hours it has to have an inspection, has to have a 100-hour check, okay? So yeah, anything for hire or then for flight instruction or provided by the flight instructor. As long as I do this stuff plus only just one more thing, that airworthiness certificate will never expire, okay? Here's how I can see if the airplane has been maintained. Remember our risk mitigation. Aircraft was one of them. I'll call it airplane because that's what I'm flying. So annual inspection, that's due every 12 calendar months. Remember, what kind of person did I say needed to do an annual inspection? Could it be a maintenance technician? Has to be an inspector. It's an inspection. Take a look at this. IA, Inspector of Airplanes. Okay? If it doesn't say IA, then that person is not an inspector, right? They can't do an annual inspection. So if I'm looking for annual inspection, I'm taking a look at here. Then it usually says ELT on the same day because those are done every 12 calendar months. Now, the only one caveat, the only one exception that we had for that airworthiness certificate to be valid is right here. Airworthiness directives. The airplane has to remain in compliance with any and all airworthiness directives. Are we familiar with a recall? Toyota came out with a car, and then the floor mats were getting pushed under the accelerator, and people were crashing, and then they recalled all of them. They sent them all back to the dealership, and they said, okay, here's your new floor mats. If I owned a Toyota, was I required to go back and volunteer to that recall? No. I could drive my Toyota and heck with it. I'm not going over there. Or I could go get my free floor mats, right? With an airplane, it's not called a recall. It's called an airworthiness directive. So it affects my airworthiness certificate. As long as I comply with all airworthiness directives, well, then the airplane is still airworthy. An example of this is on some Cessna 172s, the seat tracks would get stuck. And pilots would think that the seat was locked. And then they would take off, and instead of the seat being locked, they take off, they go like this, the airplane comes up, and the seat goes back. What's the only thing they're holding on to? Control yoke. Ah! All right, so they crash. Well, then the FAA says, okay, we have to have an airworthiness directive. Everybody that owns that kind of Cessna 172 has to change the seat tracks. Okay? So I could find it on the airworthiness directive registry page on faa.gov. Okay. Flight instruments, engine system management, safety equipment, additional night requirements. Certain things are required. Well, I can look in the rule book. If you look under, I think it's, and I don't know all the numbers by heart, but 91.203 or 205, something like that, will show you all of the required equipment you need to fly that airplane. Some of the stuff we have is optional. I don't need it to fly the airplane. Some of it, the FAA tells me, you have to have this work. Very important that you know that, because before you take these airplanes, remember the whole idea, the first thing that I'm supposed to do is solo. which means who's piloting command? Whoever's soloing. You're the only one in there. Somebody needs to command it. Hopefully it's you, right? It better be. You have to make this decision of, do I have all the equipment that I need to make this flight? Okay? So some of the stuff you need, easy stuff for flight instruments, very, very little. I need an airspeed indicator, an altimeter, and a magnetic compass. If any of that stuff is broken, you cannot fly. Okay? No matter what else you have that's working, you cannot fly. Safety equipment. You need a red or white anti-collision light. Seat belts. Front seat shoulder harnesses, emergency locator transmitter. If for hire or going beyond gliding distance from shore, I need flotation device. I had a question about flotation device, right? If for hire, over water and gliding or beyond gliding distance for shore, and a signaling device. Okay, so that's all my safety equipment. Engine and instrument monitoring indicators. I need a there's all kind of stuff. Look at all the stuff I need. Tachometer, manifold pressure gauge if I have a constant speed propeller, fuel gauge for each tank, oil temperature gauge, or oil pressure gauge, a temperature gauge. Remember I said some airplanes have liquid cooled? We have one of those. Well, you guys don't need this in the training airplane, but we need this in that airplane. Landing gear if I have a retractable gear. Night requirements, I need position lights, which is that red, green, and white light. Adequate source of power, spare fuses or circuit breakers, and a landing light if operated for hire. Now, some of the stuff in the airplane might not work. As long as it's not any of this, that's okay. Nothing wrong. I'm saying some of the stuff might not work. I might have an ADF, navigation radio, that is not used very often by anybody in the United States, the Caribbean, South America, wherever. Okay? It's in the airplane. It doesn't work. I'm not going to cancel the flight because of that. But I still need to report it to maintenance. And it's supposed to have this label on it if it's not operating properly. It has to be placarded that it's not operating properly. Remember I told you guys I'm kind of a real person. Okay. You won't find all of the inoperative stuff placarded in op on any airplane, no matter where you are. That doesn't mean it's not, that doesn't mean that that's right, but what I'm saying is, before you cancel the flight altogether, go tell somebody, try to work on getting that fixed, but if it's just not working, it's just not working, okay? Yes, I understand. We're supposed to report it to maintenance. We're supposed to put in op, but don't be terribly surprised if you find one that's not placarded. Because it probably was placarded in op, and then somebody else got in there and pulled the sticker off. That's what we run into, that kind of stuff. So, anyways. Okay, kinds of operations. The book is fun because it starts talking about stuff before we've talked about it, such as VFR and IFR. By this point in time, I'd expect everybody to really not know VFR or IFR. Visual flight rules or instrument flight rules, okay? And then day or night, well, of course I know the difference between those two things. But if I'm operating VFR, visual, during the daytime, well, then I need all of this stuff, whatever's marked as a 1, or however many I might need. In this case, is all 1s. If I'm operating nighttime, well, then I need some extra stuff. If it's IFR, I need some additional equipment. So depending on what kind of operations I'm conducting, I may or may not need more or less equipment. Okay? Like I said, the ride is going to get a little bumpy from here. So, do I have any questions at all?